Software for virtual reality. Headset software. Core programs and interfaces that power the VR headset, enabling its functionality and connection to applications. Windows Mixed Reality. OS designed to integrate VR and AR with Windows platforms. Supports a variety of headsets and apps. Oculus Home. Interface and app store for Oculus devices, offering VR experiences, social features, and settings. Steam VR. A widely used platform compatible with various VR headsets, offering access to VR games and applications. User interface. Motion controllers. Interaction is achieved through handheld controllers for navigating menus and manipulating objects. Gaze-based interaction. Focuses on where the user is looking to select or interact with objects. Voice commands. Enables interaction through spoken words for hands-free control. Content creation. 3D modeling. Tools to create 3D objects and environments for VR. Examples. Unity. Game engine with VR plugins for creating interactive worlds. Unreal Engine. Known for high-quality rendering and realism. Blender. A free tool for 3D modeling and animation. Animation. Keyframe animation. Manually setting motion for objects or characters. Motion capture. Capturing real-world movement and applying it to virtual characters. Procedural animation. Algorithms generate movements based on interactions or physics. Development tools. Integrated development environments, IDEs. Software used for coding and building VR applications. Examples. Visual Studio. IDE for programming VR applications. Unity Editor. Intuitive editor for designing and scripting VR environments. Unreal Editor. Advanced features for designing high-fidelity VR experiences. Debugging and testing. Tools for ensuring VR applications run smoothly. VR simulator tools. Test applications without requiring hardware. Performance optimization. Improves frame rate and reduces latency. Quality assurance. Rigorous testing for a seamless user experience. Interaction frameworks. Input handling. Frameworks for processing input from controllers, hands, or other devices. Hand tracking. Recognizes hand movements for natural interaction. Gesture recognition. Identifies specific gestures as commands. Haptic feedback. Simulates touch sensations using vibrations or pressure. Locomotion. Teleportation. Instant movement to a new location within the VR space. Continuous movement. Smoothly walking or running in VR using joysticks or natural movement. Redirected walking. Trick users into walking longer distances in a limited space. Graphics rendering. Stereoscopic rendering. Generates two slightly different images for each eye to create depth perception. Lens distortion correction. Adjusts visuals to account for distortion caused by lenses in headsets. Chromatic aberration removal. Reduces color fringing caused by headset lenses. Eye tracking integration. Optimizes performance by focusing high detail where the user is looking, using eye tracking. Peripheral quality reduction. Decreases rendering quality in peripheral vision areas to save resources. Audio systems. Spatial audio. Replicates realistic sound from all directions. Head-related transfer functions. Adjusts audio to match how we naturally perceive sound direction. Ambisonic surround sound. Advanced 3D sound encoding for VR. Speech recognition. Recognizes and processes spoken commands. Text-to-speech. Converts text into spoken words for communication or feedback. Application packaging. Preparing VR apps for distribution. Standalone executables. Apps that can run independently on devices. App Store submissions. Uploading apps to platforms like Oculus Store or Steam. Cloud hosting. Stores VR content online for easy access and sharing. Multiplayer networking. Enables shared VR experiences. Streaming platforms. Streams VR content without downloading files.